figure out. So the first step is to write the PDF of X. So write the probability density function of the random variable X. So how to write that? So we write that, so my goal is to help you understand how to write the mathematics clearly. So this is the probability density function of the random variable X, that is uniform 0, 1. So understand that it's uniform. So between in this 0, 1, it's taking the value 1 and 0 otherwise. That means rest of the region, it takes the value 0. So this is the density function. So next is the definition of, let me know if you have any questions, students, okay? Let me know if you have any questions. So the next definition, it's a simple problem for beginners. So the next question is, what is the definition of expectation? So the definition of expectation for a continuous random variable like this is simple. It's, it's X, the average with the probabilities. So here, here understand one thing very carefully, that the probability is not fx dx. Okay, probability is this density is not the probability. So what is this density? Let's understand it a little bit details. So if you have this probability density curve, let's say this is x and the height is f of x. So then what we are interested in is the area in this small region. Okay, so what is the small region? This is the length dx. So the very first point, this one is, let's say, x, and the second point a bit beside with x with a length of dx is nothing but x plus dx. So this area under the curve is what the probability is. Okay, so this is nothing but the probability. So this area under the curve is nothing but the probability that the random variable is taking values between x and, or yeah, since it's continuous, it's x and less than or equal to x plus dx. And this is nothing but, you can see it's a very small region. So this area is nothing but the height, since the dx infinitesimally is small. So this area is nothing but approximated by the height. The height is nothing but what? F of x. And the length is dx. So this is approximated by the density function times the dx. So this is what the probability is. Okay. This is what the probability is. Are you understanding, guys? Any questions out here? Did you understand? Whoever out here is present. Any student out here from the beginning? Did you understand this? So fx dx is what the probability is of x lying between small x and small x plus dx. Okay. So this is the basic definition of density function. So the question is very simple, Rohan. If x is uniform 0, 1, then you have to find the variance of x. I'm trying to use this problem as an example to teach the very basics and also do the computation. Can you see the question, Rohan? So yeah. So next what? So this is the basic definition of probability density function, because someone was asking the question that what is the probability density function? So this is the probability density function. Okay. So now let's move ahead to define the expectation for a continuous random variable like this. So expectation of this of any random variable or continuous random variable with a PDF, probability density function fx, is defined as so for every x, so essentially around every x, this is the probability So fx dx is the probability. So this fx dx is the probability of taking values around x. So this is the probability of taking values around x. And this is the weight. The x is the weight. So the thing that you observed. So this is the weight. Sorry, this is the weight. So the weighted average. And this is the x, the value that we're observing. So we are taking the weighted average of the x's. And the weights are equal to nothing but the probability of observing values around that x. Okay, that is what the definition of expectation is. And here we are only taking values everywhere actually, but here we call it something called this. So this is called the support. So what is the support? The support is those values where x, the random variable take is random variable x is taking. This is those values in the sample space of random variables where x, the density of x is actually greater than 0. Okay. So why will we integrate unnecessarily over the non-zero or over the 0 region? 0 where it's not taking probability, like where it's not taking values. We'll only take that region. This is called the support. All of you okay with this? Any questions, guys? I'm asking to the students who are beginners. Any questions? Because this is addressed towards the beginners. I am not teaching advanced. So why is fx assumed constant around dx? It's an overall approximation, as I said. It's an approximation. If you want to formalize this, always you have to, it's an approximation. Exactly. I said an approximation, not equal to. So if you want to formalize it, you have to do it using Riemann summation. Okay. So I'm not going to that. I'm just taking, so there are multiple levels of learning probability. So one is understanding the intuition, and that's my job as a teacher, and then going into the fundamentals and doing the very Riemann summation mathematics out there. So that's the second level. So probably that's for a different video, but this is for this beginner students. So we have the probability. This is the weight of the probability of taking values around x, and this is x, and this is a weighted average. So this is the definition of expectation of x. So using that as an example of the uniform, we get that here, observe, if you remember, if you remind yourself, the uniform has the density 1 between 0 and 1. So it has, this is the support of the uniform random variable. So what we do, it's very simple. So it's integration 0 to 1. Actually it's 0 minus, but I'm not going to that definition of integration right now. So I'm assuming that you know indefinite integration, definite integration, and you know how the limit is formed. But yeah, in this case, it's x, and here fx dx is nothing but 1 dx. So it's dx. And it's a very simple integration, it's x squared by 2, and it takes values from 0 to 1. Now comes the another beautiful idea called the law of the unconscious statistician. It's called the lotus. The law of the unconscious statistician. So this terminology is taken from Blitzstein. So in this law of the unconscious statistician, what it says that if x has a density, let's say, x follows this PDF, this. It also happens for, the discrete random variables. So I'm just talking about PDF right now. If x follows this PDF, f of x, and let's say you take a function g of x. A g of x is a function of the random variable capital X. Yes, I will also upload this. Actually, I have to again use money to buy the StreamYard, so via which I am streaming. So it wants to take money from me to stream multiple places, and I don't want to really invest right now. So I will see what we can do. But I can download this and upload it to YouTube. Okay, I will try my best. So my goal is to I wanted to stream both on YouTube and Instagram together. So this gx, so this law of the unconscious statistician says that if you have a random variable g of x, which is a function of gx, this to find the distribution of this is a huge task. I'm telling you, find the distribution of this is quite hectic. If it's not an usual function, quite hectic. But the law of the unconscious statistician says that if you want to find expectation of this gx, if you want to find expectation of this gx random variable, it has a beautiful, I understand, I will upload it, okay? So it has a beautiful expression of, oops, I will come quickly, my Mac has no charge. Just give me a minute, guys. Yeah, it's finally charging. So, yeah. So the expectation of this gx of this new function gx is, as I said, gx is very hard to find. The density is hard to find, okay, of this new random variable gx. So the way to find it is, it's very easy, okay? So which is just apply the function gx. Say here it was x, so apply the function gx, and then you multiply with the density of x. It's very simple. Apply this function gx as if you're replacing x by gx, okay? As if you're replacing x by gx, and you apply this. Just in normal expectation, it was x fx dx, but here it's gx f x dx. The reason being, you can prove that the derivative, after you do the transformation, there is a Jacobian kind of sense. So there's a change in the space. So the relative change in the space gets cancelled out, okay? And that's the whole idea. So that's why it comes out to be this, and it's called the LOTUS, law of the unconscious statistician. So variance of a random variable x is defined as expectation of x square minus expectation of x whole square, right? That's the different definition of variance. It's very simple. Again, this is addressed towards the beginner students. So now, using the law of the unconscious statistician, we already calculated the expectation. We have seen how to calculate the expectation. We have got it to be half. So I didn't complete it. We have got it to be half. So this is half square. And the expectation of x square, we can use the law of the unconscious statistician. That is integration 0 to 1. Here, gx is nothing but a capital X square, right? So it's small x square here, small gx times the density of uniform 0, 1. That is 1. So you get this. So that's the basic idea. And here you can integrate it simple to get it 1 by 3. So you get 1 by 3 here, and you subtract it, and you will get 1 by 12. But the two important takeaways, I will end the live if you want. Do you want to discuss another problem, or I wanted to discuss another difficult problem, a bit more difficult problem. Do you want to discuss that, or that's for a different live? What do you want? Let me know. So the basic idea that I want, till then, I will revise what I have said. The three things I have discussed today. Number one, I have discussed what is the definition of a probability density function, PDF, f of x. I have discussed how do you define an expectation? What is the meaning of expectation? What is the definition of expectation? In fact, I also defined like what does the integration means, both intuitively and mathematically, with intuition. And here the very basic fact that fx dx is actually the probability, not fx. So the expectation is, I have also defined it, intuitive and mathematical. And then I also defined the law of the unconscious statistician. So I have defined it, Rohan, that expectation is nothing but the weighted PDF, and also define what this means, as you can see on the blackboard, on the whiteboard. What is a basic definition and intuition of expectation? It's not average of PDF, but average of the values the random variable x is taking. It's the average of the values the random variable x is taking multiplied by the weight, where the weight is defined by the PDF. It's not the average of the PDF. Understand? Like, what is average? Average is something that you observe. Okay, average of certain numbers. Here, it's a continuous set of numbers. And how do you take it? Each number, around each number, there is a probability of it occurring. This is a measure of it occurring. So you average with that. It's a weighted average, where the weights are the probability of it taking values around that region. Does it make sense, Rohan? So the law of the unconscious statistician, I also defined. And I applied it to find out the expectation value, expectation of x square. So this is how to find expectation of a gx, of any function gx. Great, Rohan. Thanks for staying till the end, Rohan. I'm happy you stayed. Okay, I hope other students have stayed too. I don't know. So this is this is what we have defined, and then we have used this to find the variance of x and applied it to uniform 0, 1. It was a very simple problem, but I wanted to always take examples of these simple problems to introduce you to the fundamentals. Okay, the fundamentals of probability, that is very important. And then advanced problems apply these ideas and do it very quickly. So I hope the beginner students, we'll say addressed towards the beginner students. This video is dedicated towards the beginner students who are starting to learn probability, finding it hard. And I hope this is helpful to you guys, okay? So I will upload this video to YouTube also. So any other questions from the students, else I'll end the live and I will solve some other difficult problem in another video. Okay, or if I do live on YouTube, I will also tell you guys. Any other questions, students? So this is what we have discussed today. So if there are no other questions, I will end the live. And thanks for joining in, all of you. So this is my second live, Swayamjit. I'm trying out again. There was a first try to do a live today, but okay, Mrinmoy, I will do that. I will do that. I will do a live on YouTube only. Let's see. So this live, these are not pre-decided. I'm trying to make it regular, probably every day, probably few days, but I'm trying to understand this process. Okay, after a long time I've been doing live, so also I want to understand where my schedule stands. So there is no, so ideally it should be around this time only, because this is morning time for me. So ideally it will be around this time, and yep, so that's all about it. So I will let you know. I don't know the answer as of now. So Mrinmoy, you're right. I will try to do it on YouTube, and I'm just trying to do it on Insta. Yeah, so trying out some new ideas to inspire people. Okay, so hopefully it was helpful, and I will see you in the next live. Bye bye. Feel free to DM me if you have any questions.